Hi everyone. Today I'm going to talk about how to do mole calculations. Before I go to the concept of mole calculations, I want to talk about a little bit unit conversion method and review this concept. What if you remember from unit conversion method, we had a solution map for unit conversion method. We should always start with a given number. We should use conversion factor properly, and the denominator always must match with the unit of the previous numerator. For example, here is asking for convert 0.10 centimeter to inch, and the conversion factor is given in the question. We should always make sure to start with a given number, as the solution map says, and we should make sure how to use conversion factor. We should, whatever given conversion factor we have, we should write it in a way to be able to use it in our calculations. So I should write it down this way, or left or the right one. I should between these two, I should use the left one here, because the unit in the denominator of it, which is centimeter, is matching with the unit in the previous numerator, which is our given number. At the end, we should pay attention. The unit in the end, in the top end, in the top of the line, basically, it should be what is asking for in the question. So I have an inch here at the end, because the centimeters are canceling out. So I have an inch here. So that's, yes, it says convert the centimeter to inch. So when I get that, the inch here, I have the inch here, I'm done, and I do the calculations. The final answer should always have the same number of sig fig with the given number. I have 2 sig fig in the final answer, which is matching the 2 sig fig in the given number. I have 4 conversion factors in the mole calculations. So I want you to put a paper in front of you and write these conversion factors. It would be really helpful for you to make a flashcard of them and repeat them. This way it will stick in your mind, and you can basically do the question basically easier this way, and understand the concept finally better. So the first conversion factor is 1 mole of an element equals to atomic mass of that element. So 1 mole of any element, doesn't matter. We have 118 elements, equals to atomic mass of those elements. So let's go to the periodic table. I chose here Li. Why I chose Li? Because I like it. No, I'm just kidding. So let's go to the lithium. Lithium here is number 3 atomic number, and always the atomic masses are in the bottom of the element. So the bottom, it says I have 6.941 gram in 1 mole of lithium. So if we pay attention, for all of the other elements is the same. 1 mole of each element equals to the number of which is underneath them, which is their atomic mass. So if you saw in the periodic table, you see that I have 6.941 gram of lithium under the lithium element. So I write down 1 mole of lithium over 6.941 gram of lithium, or 6.941 gram of lithium over 1 mole of lithium. So let's do a question. How many moles is in 0.50 gram of lithium? We always start with a given number. like as we said for the unit conversion method, we start with a given number. Now we should choose between left or right. I should use the one that I have gram in the denominator, which I use here the left one, and the final answer is going to be 7.2 10 to the power of negative 2 mole of lithium. If you pay attention to the last equation, the top unit is always, should always be the same unit as what is asking for in the question. So is they asking for how many moles, and at the end I have the mole of lithium here. So we are okay. Then my final answer should have basically has 2 sig fig, which is matching with the 2 sig fig in the given number. The conversion factor number 2 is 1 mole of an element equals to 6.022 10 to the power of 23 atoms of that element. So for any element, 1 mole of that element equals to Avogadro's number, or 6.022 10 to the power of 23 atoms of that element. I chose here lithium, as if you remember, I said I like it. I'm just kidding. So I can write it in 2 ways. 1 mole of lithium over the Avogadro's number of atoms of lithium, or flip it. Let's do a question. How many atoms are in 0.50 mole of lithium? I start with a given number, and then from these 2 equations, I should use the one that in the denominator, I have the mole of lithium to be able to match with the unit in the previous numerator. And what is asking for always in the question, which is atoms, is always here should match with the top unit in the final equation, which is is atoms. So my final answer is 3.1 10 to the power of 23 atoms of lithium. So make sure that you have a 2 sig fig in the answer, which is matching with the 2 sig fig in the given number. You might ask now yourself, how do I know which conversion factor I should use? Why she used in the last question number 1, and for this question number 2? You should pay attention to the question. In the question is asking for lithium, which is an element. So I would recommend you to write on top of it, okay, here they ask for an element here for me. There's a lithium, so it's element. If you go back to the conversion factor 1 and 2, you will see both of these are basically used for elements. So I have elements in them. So I can use either number 1 conversion factor or number 2. But in number 2, I have atoms in the conversion factors, which is Avogadro's number atoms of that element. So I choose here to use number 2 because the question is asking for atoms of that element. So you should make sure to read the question carefully. Conversion factor 3 and 4 are about compounds. So 1 mole of a compound equals to molecular weight of that compound. Here, as I said, this is specifically for compounds. So compounds, as we know, are 2 or more elements. How we find the molecular weight of the compounds? We add up the atomic masses of the elements in the compounds. For example, here I chose LiCl. Why I chose LiCl? Again, because I like it. No, I'm just kidding. So let's go to the periodic table for look for lithium and chlorine. So lithium, underneath is its is atomic mass, which is 6.941 gram, and under chlorine I have 35.4527 gram. If you right now put them in the calculator and add them up, you will find out this number comes 42.3937 gram. So that would be my conversion factor. 1 mole of lithium Cl divided by 42.3937 gram of lithium Cl, and I flip this equation. Now let's answer a question. How many moles are in 0.50 gram of lithium chloride? We always start with a given number, which is part of the unit conversion method. Then we see, okay, which of these I should use. I should use the one that the denominator has a gram. So I'm going to use the left one. And then my final unit in the top is mole, which is what is asking for in the question, which is asking for mole. So I'm good. I can do the calculations. And the final answer has 2 sig fig, which is matching with 2 sig fig in the given number. Let's go to the last conversion factor. 1 mole of a compound equals to, again, 6.022 10 to the power of 23 molecules of that compound. If you go back to the conversion factor number 2, we had this number, but in atoms. For the compounds, we use this number in molecules. How I can write it down? I can write it 1 molar lithium Cl over Avogadro's number in molecules of LiCl and flip it. Let's do the question. So I want to talk about how I can use one of these conversion factors, these 4 conversion factors, to answer this question. How many molecules are in 0.50 mole of lithium chloride? Okay, in this question, I have lithium chloride. So which conversion factors having compound in this structure? Number 3 and 4. Number 3 and 4 conversion factors. So I should basically focus on number 3 and 4 conversion factor. So now then is asking for molecules. The only one that has a molecule in it is equation number 4, conversion factor number 4. So I'm going to start with a given number, and I'm going to use number 4, and I'm going to use here the right one to be able to cancel out the units, and the final answer, which has 2 sig figs, should match with the number of sig figs in the given number. So if in the question you have elements or they ask about atoms, in an element I use the number 1 and 2, and number 3 and 4 are used when you have a compound in a question. For example, here LiCl, and also they ask for molecules of that of the compound. So this would really helpful for you to pay attention. Now, how to use multiple conversion factors. Let's start with a question. How many atoms are in 0.50 gram of lithium? Okay, let's see which of those 4 conversion factors I should start with. I have a lithium, which is an element. So for sure, I should use either number 1 or number 2 here, right? Because they talk about elements in these 2. So I'm gonna start with a given number, and then the first thing, whenever you see something other than mole in the question, you should convert to mole. Again, if you don't see your given number is in the unit of mole, the first step is converting to mole, because mole is used as a bridge in conversion factors method. Okay, so we start with a given number. Now I'm going to use conversion factor number 1, and I'm going to convert, and here I'm going to choose the left one. But when I do the calculations, the unit in the top is in the mole, but what I'm asking for in the question is atoms. So I'm not done yet, guys. I should continue until I have atoms in the top end of the equation. So we need more than one conversion factor here. So now it converted to the mole. Okay, how I can convert the mole to atom yet? I should use equation number 2 here because I have atoms in it. So I'm going to use in the second one a mole conversion factor. I'm going to use conversion factor number 2, and I'm going to use the one that denominator has a mole in it. I'm going to use the right one and make sure. So here the unit is matching what is asking for in the question. So I'm done, and I can multiply the top ones and divide by the bottom numbers. Make sure your final answer here, which has 2 sig figs, should be the same as the number of sig figs in the given number. Okay, let's do another multiple conversion factor. Okay, how many molecules are in 0.50 gram of lithium chloride? So I have a compound here. So what should I do? I should use equation number 3 or 4 because I had compounds in those two. Okay, and the first thing I said, we should start with a given number, and we should make sure if we don't have a unit in the mole or the given number in mole, we should first convert to mole. So what I'm going to do, I'm going to use conversion factor number 3, and I'm going to write it in 2 ways, and I'm going to choose the one that is matching with the previous unit. I convert to the mole. But my final unit in the top is not matching. That's a really good time to talk about that molecules are not moles, guys. Please write it down somewhere. Molecules are not moles. Mole is not abbreviated of the molecule. Okay, so write it. So whenever you see molecules, is nothing related to the mole. Okay, so we should go one more step. What do you think, which conversion factor I should use here? I should use conversion factor number 4, which I should convert the mole to the number of molecules. I should use the one that have a mole in the denominator. So I'm going to use the right one here. And again, we should make sure I have molecules here, which is matching to what is asking for in the question. So I'm done, and the final answer has a 2 sig fig, which is matching with 2 sig fig in the given number. Okay, let's a little bit review what I said. So whenever you want to answer question in the mole calculations, first see if you have a molecule you have a compound or element. If you have a compound, you should use conversion factor number 3 and 4. If you have element, you should use conversion factor number 1 and 2. So this way you have only 2 that you have, 2 conversion factors you should focus on. Then if they ask for the molecules, or molecules, you should use conversion factor number 4. If they are asking for how many atoms, you should use conversion factor number 2. So this way, you kind of uh, get idea how to use this conversion factor. There is another question that I will for sure give in the exam. So please follow me about this question. How many atoms are in 0.50 gram of lithium chloride? Okay, I have 0.50 gram here, so is not in mole. I should convert it in a mole. I start with a given number. I should use conversion because it's a compound. I use conversion factor number 3. I convert to the mole. Then I see, okay, when I have a compound and when I want to use, the next step would be to find the number of molecules. I cannot go from a compound to number of atoms. It was not in one of those conversion factors, right? There is nothing you can see between a compound and number of atoms in the conversion factors. So what you're gonna do, you are going to convert to the mole, then you're gonna use conversion factor number 4 to find the number of molecule. Then you're gonna look at your compound, which is LiCl here. I want you to see how many elements are in this compound. There are 2 elements are in this compound, 1 lithium and 1 chlorine. So we can conclude that we have 1 atom of lithium and 1 atom of chlorine in this compound. So I'm going to write down, okay, I have 2 atoms of lithium and chlorine in 1 molecule of lithium chloride. And I get the answer. Your final answer has 2 sigfig, which has the same number of sigfig in the given number. If you pay attention to the previous equation, which is answer is 7.2, 10 to the power of 21 molecules of LiCl, but whenever you got the atoms here in the molecule of LiCl, because you have 2 atoms, your answer double up in the bottom one. We said, okay, I have 2 atoms, so my answer compared to the previous equation doubles up 2. So let's again review. These are the 4 conversion factors you should memorize and make flashcard of them. And this is basically exam yourself. I want you to pause here and answer these questions. Either you can use conversion factor number 1, conversion factor number 2, or conversion factor number 3, or conversion factor number 4, or combination of them. So the answers are here highlighted in red, and that's it for this concept.